Welcome to Chapter 2. We're starting with Section 2.1, Linear and Quadratic Functions and Modeling.
This chapter guaranteed to mess you up a little bit, so you want to make sure that you...
Why would you start off that way?
Well, because they need to be warned.
Okay, this is your warning. I don't think that that's true. But...
Baby steps and you'll be perfect.
Okay, we're starting off with the definition of a polynomial function. You've got all of this math jibber-jabber here, which is basically telling us that if we have a polynomial function of degree n, we've got the leading coefficient there is a of n, which is good.
Writing polynomial.
Oh, you're writing a polynomial.
I'm just going to, for example.
Here's an example of a polynomial function that you might see in your day-to-day life. I think there's also maybe some examples on the next slide.
Nice.
Don't get too carried away.
I won't.
Okay, so there's a polynomial. Like most things like you've done so far have been polynomials in like Algebra 2. So the key to a polynomial function is the exponents of your x's have to be 0 or larger.
Integers?
Integers, yes. Integers that are 0 or larger. So that -1 there, how does that have an exponent of 0 or larger?
It's really cool. This guy is a super secret one. He is x to the 0 power.
Because anything to the 0 power is 1.
Your dead grandma to the 0 power?
I don't have a dead grandma.
I do.
That's awkward. So, I think that's what we need to know about polynomial functions.
Rock on. Slide 2 coming up.
Okay. All right, so we have a basic definition of polynomial functions. Example 1 asks us to determine which of the following things we've got here are polynomial functions. For those that are, state the degree and leading coefficient. For those that are not, explain why not. So f of x equals 2x squared minus 3 plus x to the 5th. Is that a polynomial function?
The secret is in the exponent. So do these meet the requirements from the previous slide? I think they do.
They do, because they are integers, they are 0 or greater, and really you can just ignore the -3. Anytime you have a number, the number is going to be fine. A number is a polynomial. So the other exponents work out, so that is a polynomial. Let's talk about degree. The degree of the polynomial is the biggest exponent.
Just a quick reminder.
Yeah, that's why this is a polynomial. Okay, the degree of a polynomial is the biggest exponent. Yes, the biggest exponent is what?
The biggest exponent in this case is fever right there.
So the degree of this polynomial is 5. Then we also need the leading coefficient. The leading coefficient is the coefficient that's in front of wherever we got the degree from. We got the degree from where he circled in green. And so what's in front of x to the 5th? Well, nothing, but actually there's a 1 there.
How many x to the 5ths do you have?
I have 1. LC stands for leading coefficient there.
That is correct.
Okay, so there it is a polynomial, degree of 5, leading coefficient of 1. G of x equals 4x to the -2 plus 3. Is that a polynomial?
The evidence is right here inside the exponent.
We cannot have a negative exponent and have it be a polynomial function.
I say shenanigans.
No, really, that's the way it works.
No, shenanigans, not a polynomial.
Okay, not a polynomial.
It's shenanigans as in not a polynomial.
Okay.
Not a poly. It doesn't want a cracker. I'll be here all year.
Yes, you will. And the reason is because of the negative exponent.
-2 is not bigger than 0 or an integer bigger than 0.
Yes.
It's not bigger than 0.
It's
It
not
fails the
bigger than
first
0.
guy.
Fails it. Okay. H of x equals 9. Is that a polynomial? Well, we kind of actually said a couple of times already how this whole there just being a number thing works. It's really like there's an x to the 0 next to it. So that's got an exponent that's 0 or larger, an integer 0 or larger, so that is a polynomial.
Let me get the right color here. So polynomial. It does want a cracker. Poly wants a cracker.
Okay. Because poly only eats 0 or larger integers.
That is correct.
There you go. And so our degree is the exponent we have there, which is 0. So degree of 0. And its leading coefficient then is what's in front of our x to the 0, which is 9. Example 1 done.
I can't type that.